The lesson that we are doing today is a continuation of the 8-5 lesson that we started last week. So it's still solving quadratics by factoring. It's just now the method of factoring is a little bit different. But it's all stuff you've seen before. The steps are the same as the previous lesson. So if you want to get those out too, that's fine. So you still need to be able to set quadratic equations equal to 0, to factor one side of the quadratic equation, set each factor equal to 0, and solve each factor for x. And then writing your answer with the curly braces. If you haven't put away your headphones by now, put them away while I'm teaching you. If you want to have that later, by all means, when we're doing your independent practice. But while I'm teaching you, no way. All right, but I'm recording right now. I'll link it in the slides later. Feel free to watch the videos from last year if you like. The practice is evens or odds. My first hour had like 25 minutes to work on it, and that amounts to 8 problems. So I expect you guys to be able to get it done in that time. If you don't, whatever you didn't finish will be homework. So have it done by the time you walk in tomorrow, because what we will be doing is going over the answers, doing an entrance ticket. So that'll be towards the beginning of class, not the end of class. And then starting another lesson. So we're moving right along. Couple things that are coming up. So unfortunately, we haven't set a date for the topic 8 test yet. Because there's still quite a bit of material that we need to go to. But the Aspire test is the next big test that's coming up. So it's April 12th, that's on a Tuesday. And at least for math, the math portion is April 12th. And there are grade bumps being awarded to those that score within a specific range. Now the Aspire test has never been given before, so they're not really I don't know what the scores are out of. I'm hoping that information gets sent to me soon. But they told us, or they printed out this laminated paper, and I know you can't really read it from where you're at. But basically, for the math portion, if you score a 428, I don't know out of what, so I'm assuming if you score high enough, then they will bump your grade up a letter. So if you had an F last semester, you could get a D just for doing fine on the Aspire test. If you had a C, you get bumped up to a B. Unfortunately, you can't really go higher than an A. So if you already had an A, whatever. But still take it seriously, because I know scholarship money is usually tied to these type of test scores. And this is basically the Aspire test is your practice ACT and SAT. Those usually have a lot of money attached to them. So when I was applying to colleges, you always have to submit your college applications early senior year, so by November. So it's usually before you've taken an SAT or ACT. Some people already have at that time. Most people don't, so they send their scores later. That's what I did. I applied to Gonzaga, which was one of my top choices. Obviously didn't end up going there, I stayed here. But they offered me the Dean Scholarship at first. But as soon as I sent them my SAT and ACT scores, they bumped it up to a presidential scholarship. Now, I don't know if you know anything about Gonzaga, but it's a great school. So especially if you watch March Madness and other college sports. And I wasn't an athlete, that was just off of grades. So any questions about Aspire, ACT, SAT, anything like that? All right, so just keep that in mind. Do take it seriously. It's not like a test that you want to just bomb because you would like to take a nap. All right, it's something that you should really be taking seriously. So we are going to start with the notes, solving quadratics by factoring. Starting with example 1. So the steps are the same as the first part of the lesson, which I do have in these slides too. All right, first step is to set the quadratic equation equal to 0. Second step would be to factor the other side. All right, so maybe write that off to the side on your notes if you don't have that already. But is this equation already set equal to 0? Yes. Yes, so then step 1 is already done. So set equation equal to 0. Step 2 is to factor the other side. The side that is not 0, factor that side. And the method of factoring has its own set of steps, right? So if you think back to the flow chart, and I'll come back to this page in a second, but like I had you re-sketch it on the day 1 notes. What's the first step that we do for factoring? Good. And then you'll look at the number of terms after that. So just while we're on here, if it's a trinomial, how do we factor it? The diamond method. But just make sure that if A does not equal 1, which we will see today, that you do this other step that is attached to it, the slide and divide. All right, but yes, look for a GCF first. Is there a GCF between 3, 9, and 12? 3. Yes, 3 would be the GCF. So always check the smaller number. If it divides evenly into the others, then great. Can I factor any x's out? No. So then just 3 is my GCF. That will go outside parentheses. Inside is what you get from dividing each term by the GCF. So what will be my first term in the parentheses? Good, because the 3 would cancel. Sorry. So x squared, what's 9x divided by 3? 3. What is negative 12 divided by 3? Negative 4, and that is set equal to 0 step. Now, sometimes you are done after the GCF step, but still check the parentheses. Since it's a trinomial, well, let's see if we can apply that diamond method. So it's A times C on top. I have a 1 in the A position and negative 4 in the C position. So what number will go on top of my diamond? Good. B will go on the bottom. What number is in the B position? 3. And what are 2 numbers that multiply to negative 4 but add to 3? 4. Good. All right, 4 and negative 1. So that way it adds to a positive. Any questions about that step? So then your GCF will still be there. So 3 is still outside the parentheses. But now the parentheses are x plus 4 and x minus 1. That equal to 0 step. So we factored it. Any questions on the factoring step? All right, then step 3, what do we do now? We're solving quadratics. So it's not like we're doing what we've done in the past. We have to set each factor equal to 0 and solve for x. All right, so set each factor equal to 0 and solve for x. And in this situation, I have 3 factors actually, because factors are things that are being multiplied together. So 3 is a factor, and each parenthesis is a factor. I know it looks weird, but just set each one equal to 0. So I have 3 equals 0, x plus 4 equals 0, and x minus 1 equals 0. And we're going to solve for x in each situation. Is there an x in the first part? No. So that really just doesn't make sense. You don't get anything from there. 3 does not equal 0. In the middle one, we can solve for x. How do you get rid of a +4?
You subtract 4.
And whatever you do on one side of the equal sign, do to the other side. What's 0 minus 4? So one of my x's in my answer with the curly braces will be -4. The other one we still need to solve for. How do I get rid of a -1? Add 1, do that on each side. And then I get x equals what? To be a +1, but yes. All right. When it's a simple trinomial that we're factoring, so when A is 1, you might have noticed that it's usually the same numbers from your diamond, but like opposite signs. That's usually what it is. But I kind of caution students from jumping to that conclusion because then they make mistakes, like they forget that it's opposite signs. So do follow through with step 3, which is to set each factor equal to 0 and solve for x. You should never have more than 2 solutions in your answer for these. So questions about that? All right, then you guys try example 2. Make sure it's set equal to 0. And when you're factoring, make sure you check for a GCF first. So try that. I'll give you about a minute and a half. If you said -2 and +6, then you're correct. Earlier, and maybe even in here, someone said +2 and -6. So again, that's a really common mistake that students make. So just kind of look closely if you did that, or if you got something different. So first thing you do, make sure it's set equal to 0, and it is. So step 1's already done. Step 2 is to factor the other side. Now that has its own set of steps. For that, you need to look for a GCF first. What's the GCF between 5, 20, and 60? 5. So check the smaller number. It does divide evenly into the other 2, so great, that's my GCF. If it didn't divide evenly into the other 2, maybe break it down to its factors and see if that fits into the others. All right, but 5 fits, so that's my GCF. It goes outside the parentheses. Inside is what we get from dividing each term by the GCF. So if you do 5x squared divided by 5, that's how you get x squared, and so on. All right, -20x divided by 5 is -4x. -60 divided by 5 is -12. Always see if the parentheses can be factored further. So they can. It's a trinomial. So we'll use the diamond method. What number will go on the top? What number on the bottom? And what 2 numbers make the diamond work? -6 and +2. So yeah, 12 has like a number of options. 6 and 2 can make a -4 as long as the negative is on the 6, so that it adds to a negative. All right, and then yeah, normally you can just take these numbers from your diamond and flip the signs in your final answer. But I think it would be wise to just continue on with the last step. It doesn't take that long. Set each factor equal to 0 and solve for x. All right, you don't get anything from 5 equaling 0. That doesn't make any sense. But over here, how would you get rid of a -6? You would add 6, and that's why the sign changes. Over here, instead of adding 2, you would subtract 2. So you do need to know how to solve equations to solve these. So questions on example 2? All right, then let's do example 3 together. That one's a little bit different. All right, example 3. Is this one set equal to 0? Yes. Let's factor the other side. Is there a GCF between 2, 3, and 5? No. Nothing other than 1. You never factor out of 1. So no GCF. But as you can see, when we do our diamond, A times C, well, there's actually a number in the A position. So what would be my A times C in this? And which multiplies to, good. So 2 times -5 is -10. That was all I caught. B will go on the bottom, which is good. So far, this is what I have. Oops, just kidding. We still need to finish the diamond. What 2 numbers multiply to -10 to add to 3? 5 and -2. So if it adds to a positive, the negative needs to go on the smaller number. So far, this is what we have. But if you remember factoring, this would not multiply to our original problem, right? X times x is x squared, not 2x squared. So what do you have to do anytime A is not 1? Divide by A from your 2 factors. Slide and divide whenever A is not 1. So then if it reduces, you need to reduce your fractions, then reduce them. Like 5/2, is that as reduced as it can be? Yes. And we learned that any remaining denominators would have to be slid in front of the variable. That's just a rule. It's like slide, divide, and slide. So it's already reduced. It has a remaining denominator that gets slid in front of the x. Over here, does -2/2 reduce to anything? It reduces to -1. So then this parenthesis, because the 2's canceled to -1, can just be -1. I don't need to do any sliding because there's no remaining denominators on that one. So questions on how we factored that? So that was the factoring step. Now we're going to do the step where we set each factor equal to 0 and solve for x. So I have 2x plus 5 equals 0 and x minus 1 equals 0. Over here, get the x by itself. Always start with the one that's farther from it. Do I get rid of the 2 or the 5 first? How do I get rid of it? Good, do that on each side. I get 2x equals what? And opposite of multiplying by 2 would be, so do that. I'm a little bit out of room, but my first x is going to be -5/2. It's okay for it to be a fraction as long as it's reduced. For the other one, solve for x. What's opposite of subtracting 1? So do that on each side of this equal sign. And x equals 1. So those are my 2 solutions. The -5/2 and a +1 in your curly braces. Questions about this process? It's the same steps, it's just the factoring is a little bit different. You have to remember the slide and divide when A is not 1. All right, go ahead and try number 4. And we'll go over that shortly in about a minute or 2. All right, so if you got 1/4 and 5/2 as your answer, then you did it correctly. Good job. If you didn't, there's lots of rooms where you can make mistakes, so just listen closely. First thing, is it set equal to 0? So step 1's already done. Step 2, factor the other side. It's a trinomial. Does it have a GCF? No, not between BH 22 or 5, right? 5 doesn't divide evenly into the others, so no GCF there. So when that happens, you have an A that is not 1, you still can do the diamond method, just don't forget to slide and divide. So after you find the factors, make sure you divide that A. What's A times C in this one? So that should go on top of your diamond. A times 5, which is 40. What number on the bottom? And here's some numbers that multiply to 40. There's quite a few options. What did you guys pick? -20 and -2 made it work. They both have to be the same sign if they multiply to a positive. And since it adds to a negative, well, that tells you they should both be negative. So that's how we get this part. Why do they divide each of them by 8? Where are they getting this dividing by 8 from? Good, that's the rule. When you have an A that's not 1, that you had to slide over and multiply by C, you need to divide it in the next step. Otherwise, you don't get the 8x squared when you FOIL these up. So divide each one by 8, reduce your fractions. What number goes into -20 and 8? 4 would be the biggest one. If you said 2, you would have had to reduce again, right? But 4 goes into -20 how many times? So we get -5 on top, and what number on the bottom? Good. And then when we reduce the other fraction, -2/8, 2 goes into both of them. What do we get from reducing that? -1/4. Now, if you kind of skip ahead and look at your answer, and it kind of happened over here too, when you reduce your fractions, your final answer is usually the same thing, just opposite signs. All right, so kind of observe that. Still, I would say just continue with the rest of your steps. So you would have had to slide, but this is what I have so far. You would have had to slide those remaining denominators in front of the x. So then I get 2x minus 5 and 4x minus 1 like they did over here. So any questions on how they got that? All right, so then they set each factor equal to 0 and solve for x. And then in each situation, solve for x. So instead of subtracting 5, we add 5 to each side. I get 2x equals 5. And then opposite of multiplying by 2 would be to divide by 2. And that's how they get a positive 5/2 as their final answer. Same thing over here. Solve for x. Instead of subtracting 1, we add 1 on each side. We get 4x equals 1. And instead of multiplying by 4, we divide by 4. And that's why it became a positive 1/4. All right, so yeah, you can observe these and kind of know like that's what it'll end up being, just opposite signs. But this is why it is like that. So questions? All right. Let's look on the back side at number 10, because the rest of them are pretty much the same thing. They either have a GCF or it's slide and divide. Yes? Yes. All right, so if you want to look at the other ones, they are posted in Schoology in the notes. But let's look at the ones where you actually have to like move stuff around. So like in 9 through 12, it's not equal to 0. So you need to make sure you do that first step, which is to make it 0. We'll do 10 together. So it's equal to 10x. Would it be easier to move 2 terms to the right or 1 term to the left? One term to the left, work smarter, not harder. So how can I make 10x become 0? Subtract it. And whatever you do on one side of the equal sign, do to the other side. Now, ideally, I would line it up with its like term. But is there a like term to go with this 10x? No. So I'm just going to write it on the other side. But if there's no like terms to combine, then just write it in standard form. So like 8x squared minus 10x plus 3 equals 0. Questions on how or why we did that? All right, from there, I'll have you guys finish it. But before you guys finish it, let's just kind of look at these other ones. In number 9, how would I make this equal 0? Add 2. So it's not always subtracting to make it 0. It just depends on its sign. So to make negative 2, 0, you would add 2. And whatever you do on one side, do to the other side. So I'm just going to rewrite these. The only one we'll actually do and go over is 10. All right, but I'll just show you the work and what it would look like after combining like terms. But you guys finish number 10 with the factoring that we covered today. So number 10, did you have to slide and divide, or was it factorable by GCF? You had to do the slide and divide because between 8, 10, and 3, there's no GCF. 3 does not go evenly into 8 or 10. All right, so that means for your diamond, you had to slide that 8 over, multiply it by the 3. I'll do the diamond over here. A times C on top. What's 8 times 3? 24. B on the bottom. And the signs do matter. So it was a positive 8 times 3. That's why it's a positive 24. What number is in the B position? So that'll go on the bottom. What two numbers make your diamond work?
-6.
So it's actually -6, -4. One of you said something different. All right, so -6, -4 is the winning combination, right? You need to have the two negatives to multiply to a positive. So they have to be the same sign, and then they do add to -10. All right, so then here's what we have for our factors, at least so far. But we still need to do that divide step. What do we divide by? Which is 8. So whatever number you had to slide, that A, you'll have to divide and reduce your fractions. What does 6 over 8 reduce to? 3/4. What does 4 over 8 reduce to? 1/2. And in both classes so far, people have said 2. Don't flip the fraction. I know your brain kind of wants to, but it's okay for a smaller number to be on top. 1/2, not 2. All right, and usually you might have noticed this pattern, but once you get to this part, you can kind of see that your final answer is going to be the same numbers, just opposite signs. So 3/4 and 1/2. Do verify it with the last step, which is to set each, oops, I'm not even done, is to set each factor equal to 0 and solve. So that would mean the sliding the remaining denominators. I get 4x minus 3 equals 0. And 2x minus 1 equals 0, and then solve them each individually. I'll do it over here because there's more room. But what's opposite of subtracting 3? Good. I get 4x equals what? And then opposite of multiplying by 4 is dividing by 4. And that's why you can see y equal to positive 3/4, like we said it would. And then when you do the other one, the 2x minus 1 equals 0, what's opposite of subtracting 1? Good. I get 2x equals, what's 0 plus 1? And then opposite of multiplying by 2 is dividing by 2. And that's how we get the positive 1/2. All right, so I'm not a huge fan of like shortcuts or anything, but if you notice that pattern, then you might be able to use that. But highly recommend just solving for the x. So any questions? All right, that covers really all we needed to cover. The rest are kind of just repeat examples. It's either GCF or slide and divide. I did show you what 9, 11, and 12 would look like after doing the first step. If you want to see the rest of it, feel free to look in Schoology. But that gives you guys like 21 solid minutes to work on your practice. If you have questions, let me know. The key is on the back wall too. So use this time wisely. All right, and now would be the time where if you want to listen to your own music.